In this course, we will cover developing strategies for ethical decision making and compliance along with advanced airspace integration strategies for complex missions. Communication strategies and decision-making during an emergency are key to response operations. The learning objectives for this module include: identify operational procedures, describe flight planning components, identify airspace requirements, apply tools to address emergencies. Remote pilots must be familiar with operational procedures and how to navigate complex missions. You'll need to be an experienced pilot with quick thinking, problem-solving, and confidence in addressing situations as they arise. When receiving a request for a flight, you must first identify what the needs or outcomes of that mission are and then implement them into a plan. Questions that can be asked include: what are the outcomes or products of this mission? Are there any outside constraints to consider, such as timing, either in the date or the duration of the mission? Within your organization, are there factors that may impact this mission, such as pilot and aircraft availability, necessary approvals, either internal or external? Once these questions have been answered, an outline for each phase of the operation can be made. Your site review will impact how pilots execute the flight plan. Even if we don't think about post-mission at the onset, it is important. Once the mission is over, someone like an air boss will need to facilitate a review and debrief. There are times with complex missions that modifications and workflow improvements are required. The selection of a platform in pre-mission planning will drive site selection for an appropriate takeoff and landing area. While there are few operating limitations for drones, the major exception is that fixed-wing aircraft require a launch and landing path to accommodate their takeoff and landing slope angles. Though some newer platforms are able to shorten this requirement with more aggressive maneuvering, the requirement for a clear area will still be greater than for a multi-rotor aircraft. Contingencies must be considered in order to help mitigate issues arising from unusable flight locations. If the area is hard to reach or requires excessive travel for the flight team, it is wise to bring along other platform options that, while they may be not ideal for the mission, could be used in the event of deviations from the initial plan. While online tools make virtual site planning more effective, an in-person site visit during the planning phase remains hugely valuable whenever it is an option. One other key factor for planning is line of sight from your operating location to the boundaries of your flight. An area that has the required space for takeoff and landing, but is obstructed from the desired flight operations area, may still not be viable. This can be especially challenging to plan for from a virtual perspective if the terrain is unfamiliar to the pilot. As an air boss, you might be coming into the mission after a site survey, or one may not have occurred. For complex missions, it is critical to understand the area and know the hazards. You should understand the lay of the land from the mission plan and site survey. From that basic understanding, it is helpful to identify any obstacles and either estimate or measure their range and height. Know the indications of power lines, buildings, and unusual parts of the terrain. Here are some examples of natural hazards: terrain, trees, and wildlife. Man-made hazards include buildings, towers, power lines, and other aircraft. Buildings, fences, and other man-made structures also present a hazard to drone flights, in particular, if it is at nighttime. Taller buildings, especially in densely developed areas, can have significant impacts on wind speed and even create turbulence. This effect is known as an ergon canyon. Towers are particularly challenging to fly near. Guy wires can be hard to judge through depth perception because of their relative size, and they don't show up well on mapping software. Luckily, the FAA sectional charts are comprehensive and updated regularly for tower markings. Power lines introduce the possibility of exposure to electromagnetic interference for drones when flying in close proximity. This makes it important to understand the connection between the controller and the aircraft, and the fail-safe mechanisms that may take over in the event of a lost link scenario. Will the aircraft hover and wait to regain connection, or perhaps execute a return to base function? Similar to the guy wires of towers, power lines can be difficult to judge when piloting, especially at the extent of visual range. We have spent a fair amount of time on airspace, but it goes without saying that pilots and anyone operating as an air boss need to know where they are operating. You need to know the airspace around you for the time you are operational and know what grounded objects prohibit flight in your intended location. On the screen is the LANCE map for Fort Worth, Texas. As you can see, there appears to be quite a few airspace conflicts. In this area, there are several major airports, regional airports, municipal airports, private airstrips, and helipads. There are schools, hospitals, and a variety of other hazards. Several helicopter manufacturers also operate in the Dallas-Fort Worth area, presenting low-level flight hazards. Know where you are, what is above you, and what your specific limitations are for that area. At a low level, airspace also includes approach and departure paths. These need to be evaluated with respect to environmental considerations like obstacles, weather, aircraft functions, and maneuvering capabilities. Even during the mission, altitude and elevation considerations are critical. Remember the regulatory limitations, but also absolute elevation. Most systems use the altitude above launch location, which means in varying terrain this can become a safety hazard if you do not thoroughly vet the height of obstacles and terrain above the launch altitude. Some emergencies are weather-induced and can be one of the greatest risks to you and your drone. Examples include lightning and precipitation. Weather forecasts should be used in the mission planning process. However, even a forecast could change while en route to a flight location, or even during the flight. Weather emergencies include thunderstorms, rain, and of course, winds exceeding capabilities. Your emergency planning needs to include confidence in weather forecasts and staying situationally aware. Wind affects all phases of flight and can have impacts not only on performance but also mission outcomes, such as data quality. Wind also has different effects on multi-copter aircraft versus fixed wing. UAS are usually limited by a maximum operational wind speed. For small multicopters, this limitation ranges from between 15 and 30 miles per hour. Fixed-wing drones generally have higher limits than similar-sized multicopters, but wind also impacts them as well. The difference between crosswind and head or tailwind is substantial, especially at takeoff and landing. Smaller platforms without vertical stabilizers also may be impacted by the wind when en route. For long-term planning, there are databases from NOAA and other sites to analyze historical wind data for specific periods of time. As much as possible, you should correlate your site selection with prevailing wind directions and velocities for that time of year. Weather history and short-term forecasts can also help. Official sources of weather show measurements that are mainly forecast unless there are reporting facilities at that location or nearby. Measurements include sky conditions, current and forecast weather activity, temperatures and pressures, as well as hazards. They are also prescribed to a much larger geographical area than a typical UAS operation would cover. Therefore, for UAS operations, it is a good idea to gather more localized weather data. In the field, weather meters can provide much more timely and accurate data. This real-time weather information will enhance the decision-making capability of the pilot and therefore the safety of the operation. A wind meter or anemometer is a device that provides the wind direction and speed. More sophisticated models can also provide atmospheric pressure, humidity, and other weather measurements that can aid the pilot. Make sure that you develop a flow for setup and teardown. This should be operationalized within your standard operating procedures. One process may suit your operational capability, or you may require variations to support long or short-duration missions. For instance, for a quick flight, you probably wouldn't deploy a tent or canopy, but that shade may be valuable for reducing pilot fatigue on an all-day mission. When determining what support equipment is required, a good first priority is communication gear. This is going to be the case with complex operations. This may include a cell phone with data access, a VHF receiver, a ground control station, or a laptop. Auxiliary antennas, range extenders, and mobile hotspots are also part of the comms equipment to consider. Of course, how you charge and recharge equipment should be on your mind as well. Efficient and effective communications improve the safety of any operation. Tuning in means finding an aviation frequency. You need to find live frequencies. Memorize some of the basic frequencies, for instance, the local CTAF frequency, or the weather frequency of the airport you typically fly near. Make sure you know how to read aeronautical sectional charts. And finally, understand pilot lingo. Understand that a pilot starts with the aircraft ID number. Listen for instructions from the control tower and be prepared to change your radio frequency. You should also have a good understanding of the phonetic alphabet. You have learned about normal procedures from a planning perspective, And now we're going to spend some time on abnormal and emergency procedures. Some emergencies require immediate and instinctive responses. There are various levels of emergencies, and while the FAA has not yet dictated to drone manufacturers to follow the standard of warnings, cautions, and notes, from most to least severe, most manufacturers attempt to follow this logic in some way. Established emergency procedures should be required to be memorized and implemented when any of these emergencies happen during a flight. We have covered this with checklists. Some common emergencies include inclement weather, strong winds, or pop-up storms, air traffic conflict, controlled flight into terrain or CFIT, wildlife, loss of link or control failure, and propulsion failure. We are going to look at some of these in more detail, starting with collision avoidance. A near-mid-air collision is defined as coming within 500 feet of another aircraft. Evasive maneuvers need to comply with right-of-way rules. Collision avoidance emergencies require the remote pilot to take evasive action to avoid coming close to a crewed aircraft. Remember, crewed aircraft always have the right-of-way, even in an emergency. Since 2015, there have been hundreds of documented incidents between crewed and uncrewed aircraft. Most of these incidents have occurred above 400 feet AGL. A risk decision needs to be made if it really is necessary to fly above 400 feet. Also, in accordance with Part 107, typically a waiver is required to fly above 400 feet commercially. Planning and execution is the starting point to preventing a controlled flight into terrain or CFIT event. Following procedures and rules are critical. As an example, if you move the home point of the aircraft to a different location, other than the launch site, the landing elevation may be wrong, resulting in a CFIT. Most autonomous flight control software is not able to account for changes in elevation along the planned flight path. The altitude for AGL will always be considered from the launch altitude. An ability to utilize geolocation to maintain constant altitude over terrain is becoming more standard. However, some aircraft are using omnidirectional sensing to avoid obstacles in other aircraft. These also help to maintain altitude. Wildlife can cause emergencies for uncrewed aircraft. Birds can attempt to knock your drone out of the air. Some systems have a roll command button to scare away birds. This can be useful depending on your location and proximity to wildlife. Wildlife on the ground can disrupt the ground control stations and may cause uncontrolled flight situations. What about bugs? Well, they too can be a nuisance. Think about having some bug spray on hand depending on your location and the time of the year. Possible aircraft errors can come from a myriad of different locations. Incorrect firmware may not include safety and known software bug corrections. Battery too low to fly, resulting in a loss of power. High current detected caused by a possible short circuit. System memory full, which results in loss of payload functionality. Defective motor and a blinking light that can turn into a CFIT situation or departure from flight. Compass malfunction that could result in the loss of heading information. An autopilot malfunction that could lead into uncontrollable flight. As a pilot or in the role of an air boss, you have the power to mitigate emergency situations. Your first course of action is to execute your emergency plans. This means relying on your established standard operating procedures. Using Air Boss is often an afterthought. Some organizations just do not have the bandwidth to slot someone into the role because they are focused solely on pilots. It is important to utilize all of your resources. It might be in a complex operation that an experienced and trained pilot from one public safety entity provides leadership support to another agency as an air boss. Lastly, relying on training and keeping up with your currency is important to remember. As of 2021, you no longer need to apply for a daylight operations waiver to fly a drone at night. Flying at nighttime takes practice and adds additional nuances for consideration. It definitely takes more planning. So what does flying at night mean? Night means the time between the end of evening civil twilight and the beginning of morning civil twilight, as published in the American Air Almanac, converted to local time. What used to be civil twilight is now considered nighttime operations. An easy way to think about this is sunrise to sunset is daytime, and sunset to sunrise is nighttime. There are some use cases for flying a drone at night. These include search and rescue, surveillance, situational awareness, photography, videography, public safety and emergency services, inspections and surveying, conservation, and agricultural. Most of these use cases add complexity to any flight or mission. Some applications require you to have additional credentials. For instance, if you are participating in search and rescue, the pilot is going to need to be familiar with using a thermal camera. Because the drone you are flying has not been certified as airworthy by the FAA, you will have to self-certify that your strobes are compliant. Manufacturers of anti-collision lights might say the strobes can be seen for a certain distance, like 3 statute miles, but you can't take their word for it since they have not been certified by the FAA as meeting the requirement. There is currently no process in place for anti-collision lights to be certified for drones. If you ever have an incident or accident, you will not want to tell the police, an insurance company, the FAA, the NTSB, a city attorney, or anyone else that you took the product packaging at face value. It's a good idea to confirm that your anti-collision lights meet the requirements. Anti-collision lights tend to blink or strobe and are usually white or red. You can use both anti-collision lights and navigation lights on your drone. You can also use multiple colors of light on the same drone, and even multiple colors to indicate anti-collision or navigation lights. In summary, every flight includes a process and should include a focus on planning. Utilize technology as a tool for efficiency. Keep in mind various obstacles including terrain, wildlife, and man-made hazards. Have a sound understanding of airspace and know where you can fly. Know your limitations and use good judgment. Have a plan for how to operate in normal conditions and during emergencies. And when flying at nighttime, think about additional mitigation strategies. For questions or more information about this module, contact information is highlighted on the screen. This Assured Safe course was created in collaboration with NC State University.